Cast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, folks, and sorry for the little delay in our start here to this webinar. We had a little bit of an audio difficulty, but I think we got that solved, and I hope you can all hear me out there. This is Jim Pfeifenberger. I'm speaking to you from Seward, Alaska, and this webinar is one of a series that's sponsored by the Pacific Ocean Education Team, or POET. And POET is an interdisciplinary team of National Park Service staff from both the Pacific West and Alaska regions. The team was established in 2008 to enhance communication, education, and interpretive ocean stewardship efforts in the Pacific West and Alaska regions. We have a number of stated goals, including planning and scheduling ocean stewardship education sessions through trainings, workshops, and webinars, and hence our bi-monthly webinar series. We've had past topics that have included things like the benefits of marine protected areas, the vulnerability of coastlines to sea level rise, or current population trends in endangered stellar sea lions. So recordings of any of these past webinars can be found on the Ocean Alaska Science and Learning Center's website, and that is at www.oceanalaska.org. I'd like to also acknowledge the assistance of Sarah Allen from the Pacific West Regional Office and Bonnie Phillips of Cabrillo National Monument for their help in coordinating this webinar series. Our next webinar is scheduled for March 21st, and that one will feature Peter Murphy of the National Oceanic and Atmospheric Administration. He's going to be giving us an update on marine debris on the West Coast, including, of course, Japanese tsunami debris and what's known about what may or may not be headed our way this coming season. So today we're very excited to have with us Luke Brander, who will be speaking on the economics of ocean acidification. And Dr. Brander has a background in environmental economics. He has a master's degree in environmental and resource economics at the University College of London. And from April 2000 to September 2010, he worked as a researcher at the Institute for Environmental Studies in Amsterdam. He obtained his doctoral degree from the VU University Amsterdam in 2011, and Luke is currently working as a freelance environmental economist, and he's based in Hong Kong. So he's actually joining us from tomorrow, where he lives. It's Friday right now. Luke's main research interests are in the economic valuation of natural resources and environmental impacts. He's worked on the valuation of wetlands, forests, grasslands, mangroves, and coral reefs, and his recent research has examined the economic impacts of ocean acidification. So I will turn the controls over to him in just a moment. First of all, I would like to say that you will have an opportunity to ask questions, and if you see, there should be a little question panel over there, and toward the end we'll open it up for questions, and you can type in your questions, and then I'll read those to Dr. Brander, and we'll answer them for everybody. If you have any comments or difficulties, anything that turns up during the webinar that I should know about, you can also type it into the chat box or the question box, and I will try to address that. Hopefully we won't have any more glitches other than our little bit of a late start here. So I'm going to see if I can click the right button and turn it over to Luke Brander, and you should see his screen here momentarily. Okay, I think we do have your screen on. At least I have it on mine here, Luke.
Okay, great. I'll put it to full screen then. I hope you can all hear me and see my screen, see the presentation. So thank you very much, first of all, for inviting me to give this webinar, and good morning from Hong Kong on Friday morning. So the topic of my presentation is the economics of ocean acidification, and I'll start by giving an outline of this talk. So first of all, I'm going to try and briefly explain what we mean by ocean acidification, and then I'll give the economic perspective of ocean acidification, the way we as economists look at ocean acidification. I'll then describe a framework for economic assessment of the impacts of ocean acidification, and give a a brief overview of the currently available damage estimates for ocean acidification from an economic perspective. I'll particularly look at a study that I was involved with that's looking at the impact of ocean acidification on coral reefs globally, and talk a little bit about the distribution of impacts and also vulnerability to ocean acidification, and then identify some of the key knowledge gaps that we have about the expected impacts, and talk a little bit about next steps, where to look next when studying ocean acidification, and finally give some conclusions. So first of all, what is ocean acidification? The term ocean acidification describes the relative decrease in seawater pH that's caused by increased uptake of CO2 from the atmosphere by the oceans. So this is as shown on these diagrams, this is a natural part of the carbon cycle, but as we pump more CO2 into the atmosphere, we increase the concentration of CO2 in the atmosphere, there's increased uptake of CO2 by the oceans. And initially this was seen as a potentially a very good thing because it means there's less CO2 in the atmosphere. But it's been relatively recently recognized that the increasing uptake of CO2 in the ocean is causing pH to decline, and this causes other problems. So this for the marine environment. And so now ocean acidification has been described as the other CO2 problem. So the first CO2 problem being climate change, and the second, the other CO2 problem, being ocean acidification. So what's now being observed over the last 20 years or so is that as atmospheric CO2 concentrations increase, increasing concentrations also in the ocean, and there's now observed data from 1990 on the impact of this on ocean pH. This is taken from monitoring stations in the North Pacific Ocean. So already these effects on ocean pH are becoming observable and also showing quite significant decreases. So one important point to note is that particularly with related to the use of the term ocean acidification, the oceans are not actually acidic and are also unlikely to become acidic. They're unlikely to reach the acidic range of the pH scale. The oceans are alkaline. Ocean acidification actually just describes the decline in pH towards the acidic end of the scale. Historically, global mean seawater has had a pH of approximately 8.16, and this has actually been incredibly stable over a very long period of time. Over the last 25 million years, global mean pH values have probably never been more than 0.6 units lower than they are today. It's a very stable pH over time. But what is projected, given the increasing concentrations of CO2 in the atmosphere, is that ocean pH will decline very rapidly over time in the coming 150 years or so. And this really raises the question of, given that marine ecosystems and organisms have evolved over time in a very stable pH environment, how are they going to react to and respond to relatively very rapid changes in ocean pH? So this raises questions about how organisms are going to respond, and the main area or the main type of organism that's likely to be impacted are those that calcify, make shells or skeletons from calcium carbonate, or from calcium carbonate. And well, the process the kind of chemistry of how this is likely to affect calcifying organisms is that as CO2 is absorbed into the ocean, it bonds with seawater to form carbonic acid. And this process releases a bicarbonate ion and a hydrogen ion. And these released hydrogen ions then bond with free carbonate ions in the ocean. And this essentially reduces the availability of carbonate ions that are available for marine organisms to make calcium carbonate shells and skeletons. So the types of organisms that are likely to be impacted are plankton that make calcium carbonate shells and skeletons, coral reefs, and shellfish mollusks. So now there's been a large amount of research, and there's a large amount of ongoing research on the impacts of this change in pH and availability of calcium ions, carbonate ions on calcifying organisms. And this diagram here that I present summarizes the results from a meta-analysis of 139 experiments that have looked at impacts of increased acidity or decrease in pH on the processes of calcifying organisms. And for some of these processes, there seems to be, currently there is relatively little impact. So on reproduction and photosynthesis, the decrease in pH hasn't been observed to have a large effect. Whereas for other processes, for these organisms, there have been much larger effects observed, for example, for growth, and particularly for calcification and survival. But still, these processes are not particularly well understood, and there's also very high vulnerability, as you can see with this these error bars on the effect of survival on different organisms. There's still a large range of uncertainty about how organisms are going to be affected, and also how they're going to adapt. Another issue of concern, so aside from impacts on calcifying organisms, then also, of course, how those feed through the food web to affect other species in and other aspects of the marine environment. There's also a concern about the impacts of ocean acidification, or the feedback effect of ocean acidification on atmospheric CO2 concentrations. The way this works is that ocean acidification is likely to result in a reduction in the biological carbon pump. So the way, or the quantity of carbon that the ocean can store. What's expected is that the rate at which the ocean will uptake atmospheric CO2 will decline as pH lowers in the ocean. This leads to less CO2 being removed from the atmosphere, and essentially this is a positive feedback effect from increasing the CO2 concentrations in the atmosphere. And because if this means that there will be more of the CO2 that we emit to the atmosphere will remain in the atmosphere, this is likely to increase the rate of climate change, and therefore damage impacts from climate change. So there's this possible feedback effect as well for climate change. So this is a problem related to ocean acidification, but we need to be careful that we don't actually double count these costs. I think it's still better to describe this effect and the costs of this effect in terms of climate change damage rather than ocean acidification damage. Essentially, climate change damage is going to be enhanced. So then moving on to what is the economic view of ocean acidification. To define it very broadly, economics is the study of resource allocation and human welfare. So what we're interested in as economists is the optimal and efficient use of the available resources that we have. And particularly in the subfield of environmental economics, one of the issues that we look at is the control or the existence of so-called external costs of resource use. So we recognize that the use of some resources results in external costs that are not borne by the users of the resource, but are borne by others who are affected by the resource use. So basically we're thinking about most types of pollution, air pollution, noise pollution, and so on, are not costs that are borne by the creators of that pollution, but are borne by others, either other people in the same location or in other locations, or even into the future, as is the case with the emission of greenhouse gases and climate change. So the economic view of ocean acidification is essentially as an external cost of using fossil fuels. The polluters, the emitters of greenhouse gases or CO2, don't pay the full costs of emitting CO2, and therefore overuse fossil fuels. And the role of economics in this issue is then to provide information about the costs of these external costs of emitting CO2 using fossil fuels. To provide information on these costs in order to inform optimal mitigation of CO2 emissions, and also to inform adaptation to the expected damage costs from ocean acidification. In other words, to inform a better, more efficient, optimal allocation of resources, that we should reduce the use of fossil fuels and the emissions of CO2, and we should also think about reallocating resources to deal with the impacts, so to adapt to the expected impacts of ocean acidification. So this is generally the role of economics in this. So the types of questions that we might ask from an economics perspective on ocean acidification are: what are going to be the human welfare impacts of ocean acidification? So what are the damage costs of ocean acidification going to be? And in economics, we tend to express these types of impacts on human welfare in terms of monetary units. So we try to quantify damage impacts in monetary terms. And the reason why we do this is to allow us to compare those estimates of damage costs directly to other costs and in the economy. And this brings us on to the second question, to make a comparison between, or to ask the question, do the benefits of addressing ocean acidification outweigh the costs of mitigating ocean acidification or adapting to ocean acidification? And what I mean by the benefits of addressing ocean acidification are reducing the damage costs. So do the reductions in the damage costs outweigh the costs of the resources that would cost us to reduce ocean acidification? This is what I very, very simply represent with this little diagram at the bottom. Basically, we're weighing up, we're comparing the benefits of doing something about ocean acidification, reducing the damage costs, with the costs of mitigation, the costs of reducing CO2 emissions. Is it worth doing something about this problem? And the third question that we might ask is, what is the expected distribution of damages across different communities and over time? And this is useful information to guide investments in adaptation. Where should we be either compensating communities that are impacted by ocean acidification, or where should we be investing in other adaptation measures to account for the expected costs, the damages that are going to occur in the future? And I should say at this point, to avoid disappointment at the end of this webinar, I don't actually have answers to all of these questions, but I'll present what information we do have at this stage. So then to describe a framework for making this type of assessment of the damage costs of ocean acidification from an economic perspective. A useful way of looking at this is to look at the ecosystem services that are likely to be impacted by ocean acidification. Ecosystem services are a useful way of linking impacts to the biophysical environment to human welfare. And ecosystem services can be defined as the benefits that humans derive from ecosystems. And in terms of the ecosystem services that we might expect to be impacted by ocean acidification, we're mainly thinking about impacts to fisheries, to the ecosystem services service of fisheries. There's both capture fisheries and aquaculture. Coastal protection, so the role that marine ecosystems play in protecting the coast and infrastructure and people that live at the coast. Thinking also about the ecosystem services of tourism and recreation in the marine environment, how that will be affected by ocean acidification, impacts on biodiversity, and also, as I mentioned before, this potential feedback effect of carbon storage in the ocean, how that will be affected by ocean acidification. So in order to assess, to make an assessment of how changes in the pH level and how the impacts of ocean acidification will feed through to impacts on human welfare, we really need to understand this entire impact pathway for ocean acidification. So starting here with socioeconomic activities that result in produce CO2 emissions to the atmosphere, we then need to understand how changes in atmospheric concentrations of CO2 lead to ocean acidification. So this is understanding the ocean chemistry of this process. Then we need to understand how ocean acidification will affect marine ecosystems in terms of individual species, and then how this will feed on to impacts on fish stocks and food webs. We also need to understand how ocean acidification will impact coral reefs, what this will mean for coral reef ecosystems. The next step then is to go from an understanding of how marine ecosystems will be impacted to get a quantitative idea and understand how those changes will affect changes in the provision of ecosystem services. So in terms of fish catch, aquaculture production, tourism, coastal protection, and biodiversity. And then the next step to understand the human welfare impacts is to relate changes in the provision of ecosystem services to changes in human welfare. And then we also ask questions about the distribution of these impacts and changes in welfare, issues of vulnerability, so which communities are likely to be more vulnerable to these changes. And there are also issues of food security, the availability of food, and questions of how best to adapt to ocean acidification. And so we not only need to understand this process and this pathway, impact pathway that affects the change, well, is likely to cause changes in the provision of ecosystem services. We also need to understand changes in demand for ecosystem services. So this essentially describes changes in the supply of ecosystem services. We also need to understand changes in demand. And this is why I draw this arrow across the top of the diagram to show that this is a dynamic process. We're looking over a period of time, and changes in socioeconomic activity will also change income levels, and also, of course, human population is going to change over time. So the people who are going to be impacted in the future by ocean acidification are going to be very different from the population that exists now that are essentially causing the problem. And so we also need to account for that, those changes in population and income when we're trying to assess changes in the welfare of future generations, populations that will be affected by this. So this is clearly a very multidisciplinary undertaking. It requires understanding of atmospheric chemistry and understanding of emissions of CO2, ocean chemistry, ecology, and understanding of impacts on marine ecosystems, how that then translates into changes in the provision of ecosystem services. And finally, the role of economics is really at this last stage in assessing the socioeconomic impacts. So how do changes in the provision of ecosystem services translate into changes in human welfare? So we really need to link up a lot of different sciences to understand this problem. So now I'll move on to looking at what we currently know regarding economic impacts. And I'll first of all start off with a study on coral reefs, what are the likely effects of ocean acidification on coral reefs, and this is a study that I was involved in. And then I'll give an overview of the available estimates that we have on economic impacts of ocean acidification. So coral reefs provide multiple ecosystem services: tourism and recreation, coastal protection, fisheries, and biodiversity. Very, very high biodiversity in coral reefs. And so we asked the question, what will be the impact on these ecosystem services due to ocean acidification? And what we do is we combine a number of models that try to describe this impact pathway for coral reefs. I give a diagram here that tries to represent the various models that we've linked together. We start here with an economy climate model. This is one of the large integrated assessment models that's used for climate change impact assessment. And this gives us information or projections for different scenarios on CO2 emissions, which then relate to changes in CO2 in the atmosphere, which we feed into two very simple models that we developed on ocean acidification. So how the changes in atmospheric concentrations of CO2 relate to changes in ocean pH, and then in turn what this means for changes in the extent of coral reefs. So this gives us an estimate of the loss of coral reef due to ocean acidification. We also take information from this fund economy climate model on future scenarios for population and income. We feed this information into a visitor demand model. So this is a tourist visitor demand model for coral reef recreation. And we also feed this information on population income into a value function, which essentially relates the value of ecosystem services provided by coral reefs to changes in characteristics of the reef, so in terms of coral area and diversity, and also to the characteristics of the beneficiaries that enjoy those services, so in terms of number of people, the number of visitors, the number of people, and their income. And I'll explain this value function a little bit more detail to give an idea of what is going to drive changes in the value of coral reef ecosystem services and the impacts of ocean acidification. We use this value function then combined with estimates of changes in coral reef area to give an estimate of the economic impact of ocean acidification on coral reefs. So I won't explain all of these models. I'll just briefly explain this value function. And we estimate this value function through a meta-analysis of estimates on coral reef values. So we collect information from the literature on the value of coral reef ecosystem services. Most of these services are not traded in directly in markets. There aren't observable market prices for ecosystem services from coral reefs. And in response to this, there's now a large economic literature that have used so-called non-market valuation methods to estimate the value of ecosystem services from reefs. And we collected 81 value observations from the literature, and we standardized their estimates to a common metric common set of units, which was US dollars per kilometer squared per year. And to give an idea of which ecosystem services we find estimates for, most of them are really for reef-related recreation and tourism. And we have some information on the value of reef-related fisheries and coastal protection, only 2 estimates, and biodiversity only 6. So this is important because essentially the value that we're collecting and then using to estimate the impact of ocean acidification is really only focused on the value of recreation and tourism. So this really limits the scope of the values that we're looking at. To give an idea of where this information is coming from, these value estimates, these studies that we've taken information from, we have quite a lot of information for the Caribbean and the Bermuda. We have some estimates for the Indian Ocean. We have a lot of value estimates for ecosystem services from reefs for Southeast Asia, and a few for Australia. But actually, what we see here is a big gap that we don't have very many estimates for the South Pacific or Pacific Ocean. So this is a gap that needs to be filled, and again, this means that the data, the information that we're using, is not necessarily representative of this area. So I'll just quickly present a few of the results from this meta-regression and value function. What we do is we use a regression analysis to estimate a value function that relates the value of ecosystem services to the characteristics of each reef that's been valued. So first of all, looking at socioeconomic determinants or explanatory factors that explain variation in the value of ecosystem services. What we see is income has a positive and significant relationship with the value of ecosystem services. Essentially, as people get richer, the value of ecosystem services from coral reefs goes up. What we also see is there's a positive relationship with the number of visitors. The more visitors to a coral reef, the higher the value, of course, of tourism and recreation. And also, to pick out another effect, we find a negative relationship between the area of coral cover of the valued coral reef and so yeah, we find a negative relationship between area of coral cover and the value of the reef, but this is on a per unit area basis. So essentially, what this reflects is the effect of scarcity. So as reefs become more scarce, the value will go up, or conversely, as they become more abundant, as the area of coral reef goes up, their value per unit area is lower. And this is what we actually observe for most goods and services and resources, that when they become scarce, the value per unit of that resource goes up. And this is quite an important driver of the change in value of services from coral reefs due to ocean acidification, that as reefs become more scarce, the value per unit area goes up. So we conduct a scenario analysis. We look at the IPCC SRES scenarios for the next 100 years. These essentially describe different storylines for socioeconomic variables for the future. So, and then relate this to different emissions paths for carbon dioxide. And as I mentioned before, we use this fund model, economy climate model, to give us information on economic activity into the future, population change, emissions paths, and CO2 atmospheric concentrations. So to give an idea of these scenarios, we're looking over 100 years, or from 2000 to 2100. And we have scenarios for population change over time, and also for the different scenarios, we have different scenarios for income change over time. We then use this information on population change and income to predict visitor numbers to coral reefs. So we use a simple model, visitor demand model, to estimate under these alternative scenarios the number of visitors to coral reefs. And the fund model also gives us scenarios for carbon dioxide concentrations in the atmosphere, which we then relate to changes in ocean pH. So we have scenarios for changes in ocean acidity over time, and we combine that information on changes in acidity to give us estimates of changes in the area of coral reefs over time under these different scenarios. And then we combine this information on population, income, and visitors with the information we have about changes in the area of coral reefs. So these are all explanatory variables in our value function to estimate the value of per unit area, so per kilometer squared, of ecosystem services from coral reefs. And what we see is that, particularly under this A1 scenario, a really huge increase in the value of ecosystem services from coral reefs. And this is really driven by this very large change in income, in increasing visitor numbers and population, and also, of course, on the decreasing area of coral reefs. So the increasing scarcity of coral reefs really drives up this value of ecosystem services from coral reefs. We then combine that information on the value per unit area with the changes in coral cover to give an estimate of the total damage cost, or the value of lost ecosystem services due to lost area of coral reef due to ocean acidification. And under this A1 scenario, just to pick out this one, what we see is this is an annual value of lost ecosystem services from coral reefs is estimated to be around $900 billion per year, which in 2100 corresponds to about 0.14% of global GDP. So we're looking at very large potential impacts. So that's one study. There's one study that I was involved in looking at the impacts of coral reefs. And here I've listed all the other economic valuation studies that I could find that have looked at the impacts of ocean acidification. One of the main points of putting it up on one table on one slide is there aren't actually yet very many estimates. So there are 15 studies that I found that have tried to look at the economic impacts of ocean acidification, and only 5 of these, there are 6 estimates, 5 studies, actually go as far as being able to produce quantitative estimates of the damage cost of ocean acidification. So the main point here is that at this point we don't actually know very much. We have very little information. There are very few studies that have looked at the economic impacts of ocean acidification. And what we see in terms of ecosystem services is that most of these studies are looking at the impact on mollusks, because that's an area, at least in terms of ecology, that we understand relatively well, that the impacts of ocean acidification on mollusks are relatively well understood. We only have one estimate that looks at the impact directly on fisheries, and one estimate that looks at the impact of ocean acidification on carbon storage. And we have this one study that I've just described looking at the impact on coral reefs. And if we look at the numbers, this estimate we have on the global impact of coral reef really dominates the picture. This is by far the largest estimate. This is, of course, a global study. Some of the other studies are just for individual countries like Norway, the United States. There are a couple of studies looking at mollusk fisheries for the US. And there's one global study looking at mollusks, mollusk fisheries globally. So at the moment there's very limited information. That's the main point. But to try and put these numbers in perspective, and so just looking at the two estimates that we have for global damage costs. This is for impacts on coral reefs and on mollusk fisheries. Looking at these, taking these two global estimates for ocean acidification impacts, making a comparison here with the estimated damage costs of climate change. So here we have the estimated damage costs of climate change. This is just taking a central estimate from a study by Richard Toll, or actually a meta-analysis of impact estimates of climate change. So the estimated annual damage cost of climate change in 2100 under this SRS A1 scenario is $14 trillion per year, and this corresponds to approximately 1.8% of global GDP. Comparing that to the few estimates that we have for ocean acidification, coral reefs and mollusks, the annual estimate for ocean acidification damage costs is 1.2 trillion in 2100. So from the little information that we have at the moment, it seems that ocean acidification, the damage costs of ocean acidification are about 10% of those of climate change. Which is still very substantial, and also, again, to stress, this is based on very few estimates with also very high uncertainties. So it's all very well looking at these kind of large numbers and global damage estimates, but perhaps more importantly, more important is to look at the distribution of the damage costs. They're not going to be evenly distributed across all communities or all countries. It's likely going to be very high localized and regional impacts of ocean acidification. So those global damage costs will be focused in specific regions. For example, the study that looked at global mollusk fisheries estimated that actually 85% of those damage costs will be impacted on China, and this is because mollusk consumption and agriculture production in China is expected to increase dramatically. Of course, that's a very large population with an increasing income, and the demand for shellfish is likely to increase. So they expect that China will be by far the largest impacted area for mollusk. For the effects of ocean acidification on mollusk fisheries. And actually there are studies now and even observations of current impacts for the US West Coast that at least in terms of exposure to changes in pH, it seems that the west coast of the US is one of the places that will feel the effects of ocean acidification earlier than most parts of the world. So this then leads on to looking at the issue of vulnerability to ocean acidification impacts. And vulnerability can be described as a combination of exposure, so changes in ocean pH, dependence on marine ecosystem services, so how sensitive communities, actually both ecosystems and human communities are how sensitive communities are, and also what adaptive capacity there is for adapting to ocean acidification. So we look at these two maps here. This gives us perhaps a little idea about which areas might be very highly dependent on marine ecosystem services that will be impacted. So looking at fish protein consumption, this is mainly in least developed countries in Africa and Southeast Asia, and then looking at the location of coral reefs. Again, of course, it's mainly through the tropics, so there may be some overlap between communities that are impacted, that are very dependent on fish protein consumption, and are also likely to be impacted in terms of impacts on coral reefs. So there are even fewer studies actually that look at vulnerability. I've just listed them. I won't go through this whole slide, but it's interesting to note that there are, of these 3 studies, they actually use fairly similar criteria for describing vulnerability in terms of exposure, dependence, and adaptive capacity, but they come up with very different results in terms of impacts on which countries are likely to be impacted. The first study finds it's mainly developed countries, the second finds it's mainly sub-Saharan African countries, and the third finds it's mainly small island developing states. So this is kind of a developing field, but clearly quite kind of fluid results. So to move on to identifying knowledge gaps and next steps. In terms of knowledge gaps, there are many. I think the 3 key things that I identify is, first of all, there's a lot of research going on biophysical impacts, particularly just at a species level. But this really needs to be scaled up and translated into impacts on ecosystems as a whole, and particularly on how that translates into changes in the provision of ecosystem services. There have also been very few ecosystem services values. The study that I was involved with looking at coral reefs is really just looking at coral reef recreation and tourism values, and we need to look at the others like coastal protection, fisheries, and so on, and biodiversity. There's also a large gap in understanding of the spatial convergence of exposure, dependence, and adaptability, so this issue of vulnerability. So in terms of next steps, I think there are many, but one next step that I pick out here is this issue of looking at vulnerability and which areas are most likely to be impacted and unable to adapt. And I'm involved in a project looking at spatial analysis to understand the human impacts of ocean acidification. This is a project funded by the US Socio-Environmental Synthesis Center. This is just starting next month, but hopefully we'll have results in the coming year. So to draw a few conclusions, first of all, economic damage estimates are very few and very uncertain. So at this stage we don't know very much. But from what we do know, it seems that ocean acidification will add substantially to the costs of emitting CO2, approximately 10% from what we know at the moment. So an additional 10% cost to emitting CO2. And this has some implications for CO2 mitigation policy. The first is that it changes the trade-off between greenhouse gases. Essentially, CO2 becomes a relatively more expensive greenhouse gas, and so mitigation policy needs to reflect this. The trade-offs are no longer just related to global warming potential, but also ocean acidification damage potential. And ocean acidification also arguably increases the urgency of CO2 mitigation, particularly as the impacts of ocean acidification are likely to occur much sooner than the major impacts of climate change. Major changes in ocean pH are really expected to happen in the next 10, 20, 30 years. And so this really increases the urgency of mitigating CO2 emissions. So thank you very much for your attention. I hope we still have some time for questions. So I'll look to Jim to ask any questions that there might be. Hello, Jim. Will you will you let me know if there are any questions to answer?
Okay, can you folks hear me now? Sorry about that, Luke. This is Jim back here. If folks have questions, please type them into the question box. And I see a few coming in. It took me a moment to find my unmute button, but I'll start with a question here for you, Luke. It says, is there research on how these knowledge gaps and uncertainties of ocean acidification may affect investment in marine-related industry? In other words, won't the uncertainty of much of these industries' futures make investors wary?
Yeah, that's a good question to look at how industries related to the marine environment are responding already. So, and I think that it's not an area that I've looked at yet, but I think that is happening, and actually, as far as I'm aware, that's something that is happening on the U.S. West Coast for mollusk fisheries. That oyster farmers, I think in particular, have been impacted recently by decreasing pH in the water. This is happening quite rapidly in the West Coast USA, and so there have been quite large changes already in that industry in terms of supply chain management and finding, I think, particularly juveniles for producing oysters. So yeah, there are already signs of industries responding to uncertainty and impacts of ocean acidification. So it's yeah, it's an interesting area to look how industries are responding.
Here's another question, Luke. It looked like your maps showed primarily tropical reefs. How is acidification likely to affect cold water reefs?
Yeah, that's a good question. I know there's research ongoing on the ecological impacts of ocean acidification on cold water reefs, and yeah, they're also likely to be negatively impacted. But actually, from an economic research point of view, at the moment there hasn't been any research on that. Not just in terms of the impacts of ocean acidification on the ecosystem services provided by cold water reefs, but there's actually been almost no economic research in any context on the value of ecosystem services from cold water reefs. So from an economic point of view, it's a very difficult area to start looking at. But I think that'll be one of the research gaps that needs to be filled.
Okay, here's another one. It looks like the estimates are primarily of losses associated with ocean acidification. Is anyone looking at the potential for gains or winners in a more acidic ocean scenario?
Yeah, that's an interesting question. Not that I've seen. There's yeah, I'm not aware of any research that has looked at winners. I know there have been some strange results in some of the results in some of the ecological research that looked at the way different species respond to ocean acidification and different ecosystems impacted. And some species are likely to positively respond to ocean acidification. So perhaps at a species level, there are potentially winners of related to ocean acidification. Essentially, it'll change marine ecosystems in favor of some species and at the disadvantage of others. But whether this then translates into any benefits for humans, I don't think that's yet been assessed.
Okay, thank you. There's at least two more questions here. One says, it looks like your current data shows the effects of ocean acidification to be relatively small in terms of percentage of gross world product. So if it's such a small percentage, will it be noticed? Will it have enough impact to get people's attention?
Yeah, that's right. In terms of percentage of gross world product, it looks like quite a small amount. It's still a very large absolute amount in terms of total impact, but with the world economy expected to grow, hopefully over the next 100 years, it looks like a small percentage. So, in a way, that's the danger of presenting these types of results as a percentage of gross world product, because it makes it look quite small and insignificant, although it's still a very large impact. So I think the better way, next way in which we should be presenting and looking at impacts is really to identify the specific regions and communities that are going to be largely impacted, because of course this potentially localized, very, very large impacts disappear when you compare it with the total economy, but potentially in a local scale, very large. And I think that's probably more effective and a better way of communicating the scale of the problem, that some communities are going to be very largely impacted.
Okay, great. Thanks for that answer. And then another question we have here, it says, what were the data sources to show protein from fish consumption at less than 10% in all of North America, including Alaska? Many native communities with subsistence economies eat large percentages of fish, but this may not be shown in measures of expenditures.
Yeah, I'm not sure. I'd have to look up what the data source is for this global map on fish protein consumption, percentage of consumption of animal proteins. But again, this reflects perhaps the problem with presenting information at national. In this case, this map is at a national level. So for North America as a whole, the consumption of fish protein might be relatively low, but of course for some communities it might be very high. So again, this is the problem with presenting kind of aggregate levels. Some communities might be much more highly dependent on fish protein than others.
Yeah, I think you've really, I mean, that's an answer that makes a lot of sense to me, yes, on some of these local levels. Once you mix it in with the national data, it does get sort of watered down or averaged out, so to speak, just because those communities are relatively small in terms of the overall North American population. Okay, well, I think that concludes all the questions that we have. I want to thank Dr. Brander very much for getting up early in Hong Kong to accommodate a Thursday afternoon time for us. Our normal time for these webinars is 1 p.m. Pacific time and 12 noon Alaska time, and that's what we'll be shooting for in 2 months when we do our next webinar with Peter Murphy from NOAA looking at marine debris. And again, that one will be on the third Thursday in March, which is March 21st. So we'll get announcements out about that. We're trying to get one more ocean acidification webinar worked in here too, and so if we get that lined up in February, why that'll come first, and we'll send out a notice about that one. Thanks everybody for attending, well, it looks like one final question came through. You have time for one more question, Luke?
Yeah, that's fine. Okay,
it says, which ecosystem service is the largest percentage of the total ocean acidification damage cost? So is there a particular service that makes up the largest percentage of the total ocean acidification cost?
Yeah, well, at the moment, from the limited estimates that we have, it's reef-related tourism and recreation by value. Yeah, the tourism is the largest and one of the fastest growing industries in the world. It's huge values, and from the study that we conducted, what we show is that demand for coral reef related tourism is going to, and recreation is going to expand quite dramatically over time, and the impact of ocean acidification on that is going to be very large, and that really kind of dominates the picture relative to what we know about impacts on fisheries. But yeah, the caveat on that is we actually at the moment really know very little about the impact on fisheries and also on coastal protection. So yeah, the relative importance of these different or the relative impact on different ecosystem services might change as we learn more.
Okay, great. Thank you very much. It really is a fascinating topic. I know that, those of us who work in the conservation business, so to speak, often hope that people will want to conserve these things just because of the beauty and wonder of them. But when we can put it in economic terms, it often makes it something that a lot more folks can relate to. So we look for these kind of opportunities to place some economic values on things because, yeah, it appeals to an audience that we sometimes have a hard time reaching. So thanks for sharing your information with us. We'll look forward to seeing what you come up with in the future in terms of, putting economic values on some of these environmental issues. So I think that wraps up the webinar for us. I appreciate everybody listening, and y'all have a good rest of your week. All right, looks like folks are logging off there, Luke, but I just wanted to personally say thanks again for especially for sticking with us through the little audio glitch at the beginning. I'm glad I figured that out because I was starting to panic, but we had about 20 folks listening in, and glad we got some good questions, and I hope it went well from your perspective.
Yeah, no, it was good. Yeah, thanks very much for inviting me. As you warned me a few days ago, it is a bit strange just talking to the screen, but
yeah, you kind of get the sense that nobody's reacting. What do they think about this? But right. So it is a little odd, I'm sure, to get used to. I've never even presented one, but I've heard that that's a little odd to do it that way. But
yeah.
Anyway,
yeah, it starts off okay, but then after a while, after maybe 15 minutes, you start to think, this is, I hope there are people there. But,
yeah. Oh, yeah.
That's
there
interesting. And then, actually, I was wondering about the other webinars that you organize. Are they? I mean, I guess the timing is difficult for me, but they sound very interesting. If it's possible to listen.
Yeah, the timing is difficult. It sounds like from your standpoint, but they are generally open. I mean, our webinar service allows us as many as 1,000 listeners, so, and we've never even come close to that. So they're essentially unlimited in our terms, and I'd be glad to add you to the mailing list to let you know when they're coming up. Occasionally, due to a presenter's availability, we have to switch the time too, but generally we stick to that time. There's a fellow who you're probably familiar with in your line of work named Dr. Jeremy Mathis, who we're trying to get to give a general webinar on ocean acidification, and I'm hoping to get him in February. I saw him give a talk last November in Sitka, and it just was a very good overview of ocean acidification and what it really means, some of the impacts. He didn't have this sort of economic impact on it, but it was just a real good overview for those of us who are talking with the public and trying to explain what it is. So anyway, I hope to get him, and the tsunami debris one is our second year of doing that. We did an update on that last year, and so that's always interesting. And yeah, I'll add you to the list.
Yeah. Regarding ocean acidification, one person who might be interesting to have is she's actually just a student, but she has a project. Amazing funding from a US foundation. I can't remember the name of it, but she basically has funding for a year to travel around the world to visit different communities, and visit mainly she's visiting mollusk aquaculture fishing communities, and discussing with them essentially explaining to them what ocean acidification is, and then kind of getting their view of how they would respond and so on. So she's been to Norway, Thailand, Hong Kong. I think she's in New Zealand now, and she's from Seattle,
Okay.
originally. But yeah, I don't know. I mean, maybe she's got some interesting stories.
Oh yeah, I bet. What's her name, Luke?
Alexis Valerie Orton. I can send you her name and email address.
Yeah, that would be great if you would. It does sound interesting, and maybe if she's even in the middle of, or when she wraps it up, she'll have some interesting analysis of it. That would be absolutely the kind of thing that we're interested in hearing about.
Okay.
You know, our series is really designed to. Oh, I'm sorry. Go ahead.
I was going to say then. I mean, the kind of. I mean, it's not actually even research. It's really just. She doesn't have to kind of produce anything at the end of this, but yeah, she just has to kind of go and talk to people. But then at least it's a lot of very kind of local information, very, at that kind of fine community level. That's probably the more relevant scale to look at this.
Well, yeah, I mean, because some of those folks are folks who may be able to really speak to real impacts, or just impacts, like you say, that are more acute for a community that's more dependent on something like that, where on the global scale it looks a little bit small maybe, or watered down. It's like for certain communities this is a very major concern. I know there's already the story around about the shellfish hatchery in Oregon that had to sort of change when they allow new ocean water to come into their facility, because it was already so acidic at certain times of the year they weren't able to grow the spat that they wanted to, and that just shows an already pretty dramatic impact of increasing ocean acidification. And so if she's churning up any stories like that, or just I would love to make contact with her and hear if she thinks what she's doing would fit into this context, and if she has something to share with us. So yeah, please send that on. It'd be very helpful.
Okay. Sure. Okay.
All right. Well, it's about time for me to go get dinner ready, and time for you to get on with your day, I guess. So have a good Friday.
Time for me to have breakfast. Yeah.
Yeah, okay. And thanks again for helping us out with this.
Yeah, no, I enjoyed doing it. Thanks.
Okay. And yeah, forward me that information would be great.
Okay, we'll do that.
Thank
now.
you, Luke.
Okay, bye.
Bye-bye.